So before we go into our discussion, I wanted to bring back up something that just very quickly advertised at the start of our session, and Joe was just alluding to it, is the new IEEE standards activity and special issue that's in progress. Joe, do you want to say a little bit about that?
So we have a new standards activity under IEEE that was just approved. We haven't sent out any announcements, or we're just in the planning stages for it. It is based on some preliminary work that Nist has done over the past couple of years, where we developed a set of elemental grasp metrics for characterizing. We were focused on robotic hands, but of course some of the test methods do apply to regular parallel grippers of the sort, and special case grippers as well. You see a URL here under the first bullet, sub-bullet. This is the document where all those test methods and metric pairs are documented that we've worked on. We did obtain some feedback from a working group within the RHGM, which is Robotic Hands Grasping and Manipulation, a technical committee within IEEE. So now we think it's time to move forward and bring this towards a more formal process. We're not just trying to stick with what we've done so far. Some of it might get thrown out, and we're looking for new ideas, such as some of the things that maybe Cindy was presenting today. So anyone interested, please send me an email. And there'll be other announcements that'll go out through Robotics Worldwide, as well as some other IEEE mailing lists, such as RHGM. So I'm sure you'll hear about it from different places. But please send me an email if you are interested, and I'm going to build a list of those who would like to participate as members of this standards activity. The second thing Adam pointed out was this, we just received approval for this Robotics and Automation letter special issue, Robotic Grasping and Manipulation Challenges in Progress. This is related to any sort of competition in the past that has you have worked towards and come up with solutions for, in addition to Nist task boards. Take a look at the announcement, follow this URL, and you'll see what we're looking for. And there's plenty of time. Papers won't be solicited until the end of January. So please consider publishing a paper in this special issue.
Anybody have any questions for Joe on either of these activities?
Maybe it would be convenient if you provided the link in the chat in case people wanted a fast way to get there.
I will do that. Let's see. RAL special issue. And I'll post the link to the Nist document as well. Okay, so the other bit that I wanted to mention while everyone is here is some of the benchmarking tools that we've talked about during today's workshop are now being distributed by the Nerve Center at UMass Lowell. The YCB object and model set, which is widely used in a lot of grasping and manipulation research. We've taken over distribution of these kits in the past year and a half, and we were recently delayed with some of the COVID restrictions, but we're slowly coming back online. And those are available for purchase, given that the kind of maturity of that benchmark, and over 200 of those kits have been distributed and used in a lot of grasping and manipulation research. And then the focus of much of today's workshop, the Nist Assembly Task Board, specifically model number 1, focusing on peg insertions, gear meshing, flexible parts, and nut threading, are also available through the Nerve Center. Admittedly, the proliferation of these boards has also been delayed, but now that we have some limited access back to our labs, we are starting to bring these back online. So there was a question from Brian O'Corn asking, what is the cost of the Nist task board? So that leads me to our, I'll say our promotional opportunity. So as attendees of this workshop, you have the ability to apply for a free board. If you are interested in acquiring more than one task board for this year, the costs, I don't have the exact figure. I believe it's about $175. It's about half the price of the actual cost of some of the materials, because we're currently have a grant to assist in proliferating these. But after this year, the cost will go up to, I think, between $300 or $400 a piece. But now that we have kind of a group of people with vested interests in the same room, we've put together a simple form for applying for the task board. And I will point out that if you are if you spoke at today's workshop, you are already getting a board for free as a thank you. Just email me your shipping address. So James, you do not need to use the URL. But for others who are interested, we have just a simple form for acquiring some information, and mostly looking at things related to how do you plan to use it. Basically writing a kind of a short abstract of your proposed research using the board. And if you're willing to publish your results, or at least report those results back to us for the type of benchmarking you plan to do. Because our goal here is to try to proliferate this benchmark further throughout the community. And the materials are available online. You can order all the parts yourself if you so wish. We're trying to make that process easier by having kind of a one-stop shop to get them from. So we have this application that will remain open until the end of the week. I'll leave the URL on the side of the screen so people have a chance to grab it while we're doing our discussion period. And if you have any questions about kind of the logistics of purchasing a board or anything like that, please feel free to shoot me an email. I'm happy to talk further about that. I know there are a couple competitions and other research groups that are starting to utilize these en masse. So we're really happy to see that. Okay then, what I wanted to use the remainder of our hour is for a discussion period. So not particular to any one talk or necessarily particular to the Nist assembly task board itself, although we would like some feedback on that. But we want to start to pull together a working group that could function inside of this IEEE standards activity that Joe had mentioned. But even just otherwise as users of the benchmark, we want to ensure that this remains relevant and that we can continue developing the benchmark or future benchmarks kind of match the needs of the community. So I just started this document with a couple bullet points on discussing kind of the current state of the benchmark. And I know that there are 3 variations of the board available. I don't know if Joe or Kenny want to start us off, if there's kind of any plans to continue expanding those variations or anything like that you already have kind of in the queue.
Kenny, you got anything? Is it okay if I start?
Yeah, you can go ahead.
Yeah, so I mean, I think we do have some plans to try to work on tolerancing. As you know, or maybe you don't know, some of you is, while the components are off the shelf, the actual task board is made of a plastic which is laser cut. And we don't have too much control over the tolerance of that laser cut board. Although it has served well in the beginning, one of the things we're going to look at is how we can produce the board design that can better, especially in the some of the insertion processes, how we can make things that are more realistic tolerances that you would find in metallic parts. And maybe we'll make some task boards available out of aluminum or something like that. And the other method of expanding these task boards that we're looking at, and it was mentioned today, is if we can come up with a 1, 2, maybe 3 assemblies that utilize all the components within a subset of the components within each task board, you know, mixed up from all 3 task boards, that come up with a product that can be built by a robot. And similar to what was done in the World Robot Summit, which was a belt drive assembly, it had an electric motor. Although there was no wiring and cable routing involved, we would probably implement that aspect. But eventually you would apply power to this assembly and it would have to perform in a certain way. In the case of the World Robot Summit, there was a fixed weight on a wire that had to be lifted by the belt drive assembly. So things like that are things that we can discuss that could make this maybe a more realistic assembly that would be built by a robot. So the task boards lead up to the overall operation of producing a final assembly as you're testing your system's performance. That's what I have. Any comments, feel free.
And did I capture this correctly, Joe? Kind of the idea is that we can use the ability of the assembly to operate or light up or move, whatever the kind of activity is, as a metric to determine if it was built correctly or not.
Yeah, yes, correct.
Yeah, I just wanted to add that there are some plans, discussion about doing a wire harness. You guys saw the cable routing. That was the first iteration of a wire harness that kind of turned into cable routing. And it didn't quite represent what you actually do for a wire harness operation. Typically what you do with wire harnessing in the industry is you have like maybe some robotic assistance, but the wire harnessing is usually done by a person in an assembly line of some sort. So if we can make a specific wire harness where you might do some cable routing, but then you'll group cables and you'll send them down different paths, and the ultimate end goal would be that you pull the wire harness out of the task board at the end, and that you'd have a finished wire harness product kind of at the end.
Is that something that is in your development queue right now as kind of a 4th board, or is that that wouldn't replace the cable routing board?
No, I think there are enough differences and changes in competencies of the robots with the 2 that I would make it a 4th board.
So I had a comment. So leading up to IROS 2019, we really appreciated getting the blank board with the cutouts in it. And we appreciated the DIY aspect where we were able to order the remaining parts and put it together. Having said that, we did notice that wear was noticeable with the hardness of the plastic, especially with that threaded connection. So it was very easy for us to you know, cut those threads into that board. We did notice the more that we practiced, the more that the easier it became to make those threaded connections to draw those, you know, M4, M6 screws in, to the point where we're wondering, you know, whether at competition time, whether we're getting a new board or one that had been, you know, used several times, and that became actually relevant. So I don't know how to balance those 2 competing aspects, that it should be easy for a person to machine at, you know, without tens of thousands of dollars of specialized tools, and how to make it consistent and durable.
Right. Yeah. We actually noticed that same issue, especially when we were doing the competition board, that you can almost thread it equally just by forcing the threads on whatever track they take. We considered doing aluminum plate that had been tapped. And I mean, we're still thinking about it. So that might be a more reasonable solution.
Or threaded inserts. You could do inserts as well.
Yeah. Yep.
Yeah, I would imagine the threaded inserts would be something you should be readily available through like MasterCar or something like that, but will require some consideration on how those then get mounted to the plexiglass board. I imagine going from a plexiglass board to a metal one I don't know how significantly it would increase the cost.
Yeah. Well, the inserts that I'm familiar with, and I'm sure there are other types out there, are typically hammered into like a wood thing for a threaded insert. Maybe it's something that it has its own tap. You tap it into the plastic and then it would have the thread inside it. But then there's problems with, okay, well, you're still putting the forces on the plastic. I don't know.
I think there are, inside, outside tapped inserts where you would screw them into the plastic, but that would be a single hand, you would put the human would apply that insert and it would be a one-time deal. So it shouldn't be, it's a reasonable approach to take, I think.
Yeah, we'll certainly look into it.
Okay. Other comments on the kind of the assembly task boards as they exist now? We've talked a lot about, the kind of the physical characteristics, kind of new plans, say for new tasks and whatnot. But I mean, one thing that was mentioned a couple times today was using them for learning applications. Many a very high number of repetitions so that you can train things like that. Are there new procedures that we should be considering for using these for other types of tests? I believe right now the kind of protocol we have for assembly and disassembly, I mean, it's fairly simple as it should be, but are there other types of procedures or protocols that we'll need to consider for maybe some of these more advanced applications?
I think it's probably fine, right? As you said, it's very easy to reset kind of the experiment with the parts that we have right now. So I would not consider any change on the board itself. It would be certainly nice to find a way to automated way to restart the experiments, but I think that's more on the side of the system itself, right? That performs the learning, not the board.
Right.
Fair enough.
I wanted to add something that's kind of a question to all the developers. We have this cable routing board. Most of you guys probably haven't seen or used it too much outside of maybe the ones who did some in the competition. The difference between the competition task board and what's currently on the wire harness board is that the columns that you thread the wire through on the competition board actually had a slot where you could kind of fit the cable through by going directly above. Whereas on the wire harness task board, it is a completely closed channel that you would have to push the head of the wire through, likely let go and regrasp, or have a second manipulator, right? You can see the green parts, the 3D printed parts, are completely enclosed. We certainly want to push, different vision solutions or dual manipulators, but maybe this isn't the place to do that. What are your guys' opinions on, how feasible is it to have those channels closed like that? do they need to have the slot in them like the competition task board did? Cool.
Maybe a better question would be, is there anyone on the call still who interacted with this board at the competition and locally?
So we didn't interact with that particular board. We interacted with the quadrant on the IROS 2019 board. That was kind of difficult for us to tackle, just because we didn't have the bench strength to do flexible cable modeling at all. So
Sure.
we were dealing with that in kind of a very rote way, just because we needed a deeper team in order to tackle. That's kind of a large turn from almost everything else on the board, and it's challenging and it's interesting, because that's a problem that has to be solved, because any large product like a car or whatever, is going to have cables running everywhere on it.
Yeah.
It's just that it was difficult for a team our size to deal with, but I think we had one of the smallest teams at IROS then.
I think that some of the aspects of fasteners are fasteners. I don't think they're going to redesign fasteners for robotic assembly. But when it comes to little plastic components for routing cables, design for manufacturing is a viable route to take. So I think that we should take that into account and come up with routing channels that are adaptable to robotics, whether we design them ourselves or we find them commercially available.
So as a follow-up question, is there any benefit to having a task board that is more vision-based like that has tasks where you specifically do have to hide something and regrasp it, or or something of that manner? Is anybody interested in that kind of task board?
To clarify, you mean a board where there are areas that will become obstructed over time or before or after you perform tasks due to task progression?
Yeah, I was kind of being vague on purpose. Maybe it's the AR tag that's in a different orientation than the rest of the board, and so that causes its own issues. Maybe there's a big vertical baffle that makes it complicated to see the parts behind it at certain angles.
I certainly think as we start to think about these as larger sets of tasks as opposed to individualized pieces, kind of I think one of James's comments earlier about thinking about how when you perform one task, how does it impact the next task? There's certainly a variety of considerations, even just for the amount of time it takes and kind of propelling that down the set of tasks you're performing, but how they might obstruct each other, or how being inaccurate on a previous step may affect your accuracy on the next step. This board certainly starts to get at some of that, and I imagine those types of challenges are things you would encounter in real manufacturing environments.
Yeah, and I was thinking maybe specific tool parts that are very similar in size and shape can cause other vision issues. Being able to identify one from the other. The Siemens gear assembly actually has the two pegs that are similar enough that sometimes they can cause issues.
Right.
It will be also on the topic of vision-based interesting to eventually have a transparent object.
Yeah. See, that's perfect. Or maybe dealing with negatives, more negatives than just round holes.
Yeah, the negative is interesting because I think in the current design of these boards, so I've always been curious actually even just about the use of the plexiglass material for reflectivity, things of that nature, where, finding the hole and assuming that your material underneath is contrasted enough color-wise that you could, see the hole from a top-down view. As you get into using things with channels or negative spaces, we have to be really considerate of how those are detected. And I'm curious of what it would introduce in terms of how to fabricate it in a way that, like our questions about threading, how to make those negative spaces that are in a repeatable fashion. Because right now I would think, okay, we etch it away until it's the sufficient depth or what have you, but that has a lot of variation implicit.
Right.
Mm-hmm.
Okay, what about kind of maybe even outside of, say, the assembly task board? Because I feel like there's kind of other there's other areas that we've touched on today that are all related to manufacturing. So some like the watch assembly, which is dealing with even finer resolution and tolerances than what the board presents, but maybe is fairly either unless there's maybe qualities of that can be applied to other domains. But what are some other areas for either assembly or manufacturing based capabilities where some benchmarking tools could be really beneficial?
I think
I
it'd
mean,
be
this.
interesting to. Oh, go ahead, Juan.
And I was quickly saying that this is probably also on the same topic, but most of the insertions right now are vertical, right? So something that requires an angle insertion or a more complicated motion to be inserted, that would be interesting. It will be also interesting to, it's still insertion, right? But if you can really deform what you're inserting, like I'm thinking about a blister or something, right? So if you press too hard, you're actually breaking it. But again, these are also probably more into the same area where the Nist board addresses right now.
And that's fine. If they fit into the Nist board, all the better.
Okay.
James?
Yeah, go ahead, James.
Oh yeah, I was saying if we're looking for inspiration, we could look at the assembly sequence planning literature. So that's something that's been going on, since the 1980s, and there are a few three-dimensional problems that have been passed around and reused, and new ones added that exist virtually as STL files. And there are many methods out there, for dealing with those 3D models and putting those together in an appropriate sequence. But I think it would be interesting to start bringing choice view of those into the real world. That's why I'm in this subfield, because we're moving from years of working on these virtual ideas to executing on them. So that would be an interesting place to look for inspiration.
Joe, did you have a comment?
Well, no, I like Juan's idea about deformable objects and insertion. I think his point was that if you apply too much force, something could fail, break.
Mm-hmm. Yeah.
One thing I wanted to mention is that the Nist task boards are designed so that you could easily fixture them in a different orientation, although based on, we make our decisions not to do that during competitions based on, how far teams get. So we try to make it, easy. I want to say easy, but we want people to succeed somewhat. But if you do move on to an overall assembly, like I mentioned earlier, up above, if we create an assembly out of some of the components from all the task boards, similar to what WRS did, it would be useful to, then you would be forced, of course, a lot of the components are going to be in different orientations. So that would certainly take care of that, that issue, requiring different orientations, where fixturing the task board would move everything in the same orientation, still just a different.
This is Cindy. I mean, just a couple of random things. One is tying knots. I've certainly seen the ability to manipulate something flexible. So can you actually like tie a knot? The other thing, so like I said, when I watched the Boeing assembly, one of the things that was interesting there is like actually having to have, this is two-hand manipulation, so like some more challenging, but like stabilizing with one hand while the other one does the manipulation. I don't know if we're at all to the point of trying to do two-handed manipulation. But, you know, something where you've got to use one hand as a stabilizer and one hand to actually pick up and put the pin in.
I think even the idea of turning some of these into assemblies is probably going to require some bit of that, depending on what they are.
I mean, I would love a robot that could thread a thread through a needle, since I can't see anymore, but that's a different topic.
Sure. All right. Other topics we want to bring up before we kind of close down. And all of this will be posted on the workshop website. And basically everything that we have today is going to live in this Google Drive folder. I'll move the document to there as well for people to reference. I've also been capturing questions that were asked today, planning to leave timestamps for where those questions are answered in the video. It's kind of my closing question is kind of, okay, so how do we move forward as a group? There's the IEEE standards activity, and that's certainly one way. Do we establish a mailing list, a Google group? What's kind of the best method for us to keep momentum in this area?
I think it's nice to have the, I mean, everybody gets tons of emails, right? But have the Google Drive with whatever, that summarizes. I mean, if someone makes a new, with all the results or new publication in using some of these benchmarks, that is organized in a way that is easy to just say, okay, these are suggestions for, we can keep growing this list that you are, this document, but also that if I want to get to know more about what is going on, who is trying what, I can go to a folder and just see all the papers and work that people are doing and links to GitHub and things like this, right? So it's nice to have. If that is also advertised and everybody uses that, that's going to be useful.
I mean, what that makes me think of is on the YCB page, aside from just information about YCB, they actually start cataloging available benchmarks and protocols, and you can download them and access them in a fairly standard way. As we start to build up a user base, it may be worth starting to host some of those on a kind of a curated basis in a similar fashion.
Yeah, I think that's a good idea. And I was recently approached by those guys because Bert Kiley's on our standards group. He's one of the leaders, and he said, this YCB benchmarking page worked out great for hosting the initial work, but it's getting a little hard. It's time to move it into the standard. So maybe this is a good first step before we bring it into a more formal process.
yeah, hopefully it's a way for people to get access to readily available access to the other work that people have done without having to go hunting.
Right. It's a good idea.